Welcome to The Explainer. Today, we're going to dive into the world of statistics. We're going to build a simple framework that you can use to make sense of any data you come across.
So let's start with a feeling I think we all know. You open a news article or you see a report at work, and you just get hit with this tidal wave of numbers and charts and percentages. It is so easy to feel completely overwhelmed, like you're literally drowning in data.
But there's a life raft in this sea of numbers, and it's called statistics. And here's the really interesting part. The word statistics itself actually has two very different but related meanings. And getting this difference, that's the first key to unlocking its power. So what are these two meanings? Well, to really get a grip on the subject, we have to pull apart the two fundamental ideas that just happen to share the same name. Think of it like this. It's the difference between the ingredients and the recipe.
Okay, so on the one hand, when we talk about statistics, plural, we mean the data itself, the raw numbers, the facts, things like the unemployment rate or sales figures. But on the other hand, when we say statistics, singular, we're talking about the method, the whole scientific process of collecting, analyzing, and then interpreting all those numbers.
All right, let's explore the first pillar of that statistical method, descriptive statistics. This is the absolute foundation. It's all about taking the data you have right in front of you and describing it as simply and as clearly as possible.
So this is descriptive statistics. You can think of it as the bedrock of our framework. Its entire purpose is to take a big, messy set of data and just summarize it in a simple, understandable way. There's no guessing here, no predicting. It's just about stating the facts of your data, plain and simple.
So how does that actually work? Well, it follows a pretty simple logical flow. First, you have to collect the raw information. Then you present it, maybe visually in tables or graphs. Next, you analyze it by calculating summary numbers, like, say, an average. And finally, you interpret what it all means.
Now we move to the second pillar, and this is where statistics gets really powerful. We're moving beyond just describing what we know and into the world of making smart, educated guesses about what we don't know. This is the great leap of inferential statistics.
This second pillar is called inferential statistics. And this is the science of using information from a small, observed group, we call that a sample, to draw conclusions about a much larger, unobserved group, the population. It's the magic of using what we can see to understand what we can't.
The best way to think about this is with a simple analogy. Soup. Imagine an entire pot of soup is your population. It's everything you want to know about. Now, you don't need to eat the entire pot to know if it needs more salt, right? You just need to taste a single representative spoonful. And that spoonful, that is your sample.
And that right there is the core principle in action. By analyzing that one spoonful, the sample, you can confidently infer something about the whole pot, the population. This is exactly how political polls work, it's how new medicines are tested, and it's how we make sense of huge, complex systems every single day.
Okay, so we've got our two pillars, describing the data we can see and using it to make inferences about the data we can't. Now let's look at where this powerful toolkit actually shows up out there in the real world.
The short answer is you'll find it absolutely everywhere. Statistics is the engine behind government policy, business strategy, and scientific research. It's used in education to track student performance, in factories to control quality, and in stores to manage inventory. It's a truly universal toolkit for solving problems.
But like any powerful tool, statistics can be misused. And this brings us to a really crucial point, the common distrust of statistics and the responsibility that comes with using it. You've probably heard this famous quote. It gets at a crucial truth. Because statistics feel so objective, they can be manipulated to support a biased argument, becoming a very sophisticated kind of lie.
And the danger is clear. In the hands of someone who doesn't know what they're doing, or someone with an agenda, these tools can be used to mislead rather than inform, by cherry-picking data to reach a conclusion they wanted to find all along.
And this brings us to the most important point. The true goal of statistics should never be to find support for an argument you already hold. The goal is illumination, to shed light on the truth of a situation, whatever that truth happens to be.
And that leaves us with one final, empowering question. The next time you see a statistic, you now have the framework to ask, is this for support or for illumination? Is this number here to prop up a belief, or is it here to help me understand the world better? Asking that question is the key to navigating our data-filled world.